We continue with our discussion of cloud physics by a description of the global water cycle. The objectives of this module are to identify these reservoirs, the principal reservoirs of water in the Earth system, and to identify the processes that link these reservoirs. A global reservoir is defined as a portion of the atmosphere Earth system that stores water in some way. It could be water in any phase, solid, liquid, or gas. As you can see in table 6.1 from your text, the ocean is by far the largest of these reservoirs, containing 97% of the water on the Earth. Glaciers and ice sheets are the second most common reservoir. You'll notice that in fact groundwater is the third largest reservoir. The problem being that it's not necessarily where you want it to be. Right now, for example, Vermont has plenty of water in the ground, whereas California doesn't have enough. There's a pretty big drought going on there right now. Finally, most important for our purposes is the atmosphere. You'll notice here that just 0.001% of the water on the planet Earth is stored as water vapor in the atmosphere. However, in any discussion of weather, this is very important because that's what gives us our precipitation and makes it humid on a hot and muggy day. Here's a depiction of the global water cycle. Essentially, in most of you can find various charts like this on the web. They all basically show the same thing, that water essentially evaporates from the ocean and is transported in towards land, and that provides most of the fresh water that people use for agriculture and other purposes. And in liquid form, that fresh water eventually finds its way back into the oceans where it once again evaporates. Of course, this just shows the net flow of water through the system. There is precipitation over the oceans, and as well there is evaporation that takes place over land as well. But there is a net transport of water vapor from the oceans through the atmosphere onto land in the overall planetary system. So that's important to keep in mind when you're looking at these charts. Also in this presentation, and you'll see this on the Moodle tab as well, this video that is a brief overview. I recommend you look at it. It illustrates in very visual form what the global water cycle looks like. Finally, we have here a simulation of the atmosphere showing all the water vapor and liquid water in the. Let me just quickly go over what we're looking at here. You see various forms of water atmospheric precipitation depicted here. In orange is precipitation, and you will see those along these wisps of cloud going here towards the poles, as well as in the tropics over here. White represents clouds, whereas clouds are made out of liquid or frozen particles of water. And water vapor is depicted by these hazy regions that you see mostly in the tropics, but also in little wisps in the extratropics as well. A few features that you see here is that much of the water vapor and precipitation occurs in the tropics, where it is very warm. You will also notice here things called atmospheric rivers, in which water vapor is taken from this tropical source and transported towards the poles. You'll see that in the southern hemisphere with these little wisps of water vapor here, as well as in the northern hemisphere with these wisps of water vapor here. You'll notice here for the northeastern part of the United States that much of this water vapor comes from the Gulf of Mexico and some of it from the Atlantic. So in general, here you will see a transport of water vapor that evaporates over the ocean and then is taken by weather systems in over land and provides most of the precipitation.